Hello everyone. In this video, we will learn about Coulomb's law, which explains the interaction between electric charges. Understanding this law is essential because it helps us understand and predict the behavior of electric charges in everyday life, from the operation of electronic devices to how the electrons and protons in atoms interact to create electricity. What is electric charge? Electric charge is an amount of electricity that is carried by something. Electric charge is like a special property that some things can have, and it can be positive or negative, like magnets. But for electricity, what is electric force? Imagine two objects with electric charge. When these charged objects get close to each other, they start to interact just like when you bring two magnets close together, and they either attract or repel each other. The electric charge on these objects creates a force, much like a magnet's pull or push, and we call that electric force. It's the force that electrically charged objects exert on each other. What does Coulomb's law state? Coulomb's law helps us understand how strong this electric force is between these two charged objects, and it is actually the math we use to measure how strong this force is between two charged particles. Imagine two charged particles, Q1 and Q2, that are placed at a distance r from each other. According to Coulomb's law, the electric force from Q1 applied to Q2 can be calculated using this formula. K is Coulomb's constant and is defined as follows. Here is the permittivity constant of vacuum, which is approximately equal to this number in SI unit. The above relationship is defined as a vector, so it shows both the magnitude and the direction of the force. According to this law, the force between two charges depends on how big the charges are and how close they are to each other. If the charges are not the same, one is positive and one negative, they attract each other. And if they are the same, both positive or both negative, they repel each other. If they have a lot of charge and are very close, the force will be strong. If they have less charge or are farther apart, the force will be weaker. The mentioned relationships show that the electric force from Q1 to Q2 is equal to the electric force from Q2 to Q1, but in the opposite direction. How does an electric charge sense the presence of another charge near it? The answer is in the property that a charge creates around it. Such properties are called field in physics. Here, an electric charge, for example, Q1, creates an electric field in the space around it. Now, if another charged particle like Q2 is placed near the first charged particle, it means that it is placed inside the electric field of Q1. So an electric force, which we talked about, is applied to it from particle 1. Now we can consider a definition for electric field. It's like an invisible influence zone around these charges where they can interact with each other, like pushing or pulling other charges from a distance without touching them. Think of a magnet that can attract or repel objects without actually touching them. When you hold this magnet near other objects, they feel a force pulling or pushing them, even though the magnet isn't physically touching them. In a similar way, electric charges create an electric field around them, and other charges placed in this field can experience the electric force, which we talked about, either attracting or repelling them, without direct contact. Electric field is calculated from this formula, where E is the electric field, K is Coulomb's constant that we talked about, Q is the charge creating the electric field, and R is the distance from the charge to the point where you want to calculate the field. The strength of the electric field around a charged particle can be quantitatively shown like this picture. According to the formula, as we get closer to the charged particle, the strength of electric field increases. And also, this increase is reflected in the greater density or number of these representation lines. We saw that the electric field resulting from a charged particle is as follows. Also, if Q is positive, the direction of electric field is directly away from it. And if Q is negative, it is directly toward it. According to the principle of superposition in electric fields, the electric field caused by several electric charges in space is equal to the sum of the fields that each of the electric charges create in the absence of other charges. Electric field is also a vector that has magnitude and direction, so we should pay attention to its direction when using it. We should remember that the direction of electric field matches the direction of the force. So if Q is positive, it is directly away from the point charge. And if Q is negative, it's directly towards it. We came to the end of this video. I hope this video has provided valuable insight and expanded your knowledge.